We're a economically deprived area. The average salary where Agra is located is around $16,000 to $17,000. About 83% of our students qualify for a reduced or free lunch through the federal child nutrition program. This community, being small, is built around the school, so the success of the school is the success of the community.
What have we learned today? Variation. Great. And we're going to say somewhere in the problem, well, what if all 20 teams don't show up? Mm-hmm. How many will we need to pull out? How many racks of basketball?
Okay. The other problem was the token problem, where the student goes to the video arcade and he's going to purchase the 8 tokens and he can play 12 video games with that. One way we could work this out if we're
They
still
said they're going to close us down for over 50 years, and we're still operating, and we think we'll continue to be able to operate because we have a good finished product.
This is with a project called Lesson Study. It's basically where we as instructors will plan our lesson, do the lesson.
It's a very thoughtful process. They're analyzing thinking, they're reflecting on their own practices, and they are able to see their own teaching through the eyes of their peers.
We're going to have several people there observing the lesson from the State Department of Mathematics. We will also have the teachers that met together this summer. They're all going to be evaluating the lesson itself.
So it's a lot of feedback, a lot of reflection. Part of the process is your individual reflection, just your thoughts, your own individual ideas about what you saw. So I just want you to choose a corner here in the gym, anywhere you want to go, where you can be nice and quiet and reflect on what you saw.
I think it's very helpful because quite often as we're teaching, we're evaluated as teachers in the classroom, but the actual lesson itself hasn't been evaluated. Is this a good way for these children to learn this? Will they remember it after they've learned it? Has real meaningful learning happened? In prior lessons, we did some graphing. We've talked about ratios and proportions, that everything's a relationship. So now we're going to put some of this to use in a real-life situation. When our team got together, we were trying to decide who was going to actually present the lesson, and we thought they would be more comfortable with what they were used to. So that's the reason I went ahead and presented the lesson. I think my colleagues were more than capable of doing so. Roz, in fact, did a little trial last week.
And I did kind of a mini lesson on it just to kind of see how it would work. And I did it on the wall. And believe it or not, the children did just about the same thing that they did here today.
It's a team effort. You've had 3 or 4 or 5 different folks look at a lesson, give you feedback, draw a diagram, how should we set this up? And that's what makes the difference. And you could see that in your work with the students.
I just thought it was really, really interesting to be an observer of a lesson that, I had a hand in writing, because typically you write the lesson and you do it. To step outside of that and be able to observe was pretty neat, especially in a collaborative group.
You're going to work together as a group to solve the problem. It's a little bigger group than what you guys are used to.
The groups were a little bit too large, and so ideally we would want this to be smaller.
I agree with you about maybe having smaller groups. And one reason would be just to have some more examples of graphs so that they could see. It might prove to them a little more that every time we have a direct proportion, the graph's going to be a straight line.
Normally they work in pairs or in groups of 4s. They almost tended to do that in the group. I noticed they would start breaking apart again into their small group thing. Their area of comfort. This is a group process. Not one person does it. Everybody's working together. Yes, Chris?
Which one are we going to be working here? I mean, because you said a bunch of 2 different ones.
Okay, you're doing problem number 1, the video game. This group over here, group B, is going to be doing the basketball games.
The dependent or whatever. Mm-hmm. How do you do that again?
Okay, remember, you're going to look in here to figure out what's depending on the other. What information are you given that determines the amount the other one's going to be? The one that does the determining, remember, is your independent. And I'm not going to tell you where it goes. You guys are going to talk about that. One group decided their labels, which was dependent and which was independent right off the bat.
How many times because before they had even done any manipulating with the numbers at all, they were labeling that graph.
Okay, so video games will go on the top?
They had tokens on the side and video games on the top before they put a number on the paper.
Because see, if tokens play, so tokens is on the bottom. Yeah. Because how many tokens? Yeah.
Yeah. So they knew in their mind which one was dependent, which one was independent, without doing any of the math to go with it.
And watching students work in an environment where I did not feel that one student felt threatened.
If Jenny purchased 12 tokens, 8 and 12. But would you make it into a fraction and divide, or would you turn it? Or would you even make it into a fraction?
Remember the 2 dots, the 8, and then the whatever you call it, and then the 12.
No.
8 to 12? The 8 to 12, which is the ratio. Yeah. Oh, words, yeah. Okay, and then you're going to put in 12 tokens on the next one.
No, you have to find out how many games you can do with 12 tokens.
Oh,
It's always supposed to get on the other ones.
you would just have to reduce it.
No.
144 divided by 8.
Let me take a look at this.
And there was a child in our group who didn't quite get it.
You guys are way out of line.
It's,
Will you look at this?
it's 18, so it
What
was
about it?
Look at it. Look right up there.
18. It's 18.
But how do you
Gee, this is hard.
When you handed out these sheets, it has the 3 different ways to write their ratios.
What are you talking about?
I know.
Look at the O.
Right up here. So that is what happened.
David got caught in that first one with the colon between them, and that was how he wanted to write it.
minus 12 is
Like that.
And because of that, he couldn't figure out how to write the proportion to find the answer.
Did you get it?
And the other children immediately said, no, 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 see, it's this way.
You get 36 games for every 12 tokens, so you have to reduce that, right?
You don't get 36 games for 12 tokens.
Yes, you do.
No.
And he was adamant. He had figured it out. There was it was 36 tokens for whatever, and he kept telling him it was 36. It was 36.
144 divided by
8 tokens
It's
for
100.
12 games. You take that and you reduce it. It goes into 4 and 6, and it goes into 2 and 3, and that's as small as it can get. And then you multiply 3 by 12, and you get 36.
But you don't times it.
What?
No, see.
Why don't you times it?
You gotta divide it by. Well, you. Okay, you explain that. Because
Yeah,
David,
explain
look,
it to me.
you have, it takes 8 tokens to play 12 games.
Go back then.
So you would have to do 12 games, or 12 games equals how many tokens?
12 tokens.
Yeah, 12 tokens.
12 tokens equals 36 games.
No, it doesn't. You don't.
No, you have
to
to cross multiply.
You have to cross multiply, and then you have to divide.
Even when the young man didn't understand, he had no qualms about arguing his case and say, okay, you told me I'm wrong, I'm not buying it, I'm going to check with one more.
But how do you get from the 2 to the 12 in your duration?
He did ask the teacher for assistance.
To multiply, divide? Okay, but I mean, if you're going from... Right.
Shelley asked him some questions, some very important questions, to kind of steer him back.
So then what do you do to the 3?
Multiply 3 by 6.
Right.
Looking at proportions and ratios.
18.
Okay. Now you see the difference? Okay.
So he came back to group and he got involved.
But all of that happened, and nobody said anything to him that was negative. Nobody said there was something wrong with what he did. How dare you go ask the teacher? We told you. None of that. They were very nice to each other. The whole process was very, very well orchestrated for a group of kids working together.
Most of the thinking went on when they were working in groups and talking about the problem.
The other group was too interested in the ratios. They almost forgot about the fact that they had to label the graph until they got through.
Each of the students was just working with the person next to them on the problem, and no one really wanted to take charge, and that was fine until somebody brought up the idea of cross products, setting up a proportion.
No, 20 teams divided by 8, the original 8, and then times that times 6.
Yeah.
When they first, they all looked at it saying, oh, we can't even figure this out. Then somebody said, oh, you cross multiply.
I agreed to observe a student called Diana. She actually grabbed everybody's attention when they were kind of unfocused, and she announced, well, remember, Mrs. Cagle said we can cross multiply.
It would be 15. 15 racks to 20 teams. You just have to cross multiply.
Cross multiply what,
But we
though?
have to have 4 points. I know. That's the next one. And then you have to put 28 down there.
Everybody else kind of took off on that.
And then they were able to all look and see if that worked out.
We have 28.
So
The first one is.
12, 18.
And she looked at the numbers 6, 8, and 20 and threw them on the page.
I just started with 6 and 8 again. It didn't matter. It wouldn't matter which one you started with.
And did 6 over n equals 8 over 20. She was going to get those 3 numbers in there somehow, and she was going to cross multiply. And she did it. What amazed me, and it does with kids like this, they, out of the ether, they seemed to pull this table together that made sense. It didn't match the math she was doing, but it was correct. And then she got talked out of it.
You cross multiply that and you should get 15. Then you have 28 teams, but there's still no racks. So you do 15 over R and 20 over 28 and cross multiply that.
Because she didn't have the mathematical thinking behind it.
That's okay, Diana. That's how we learn. We make mistakes. We see what happened.
Erased the table, went for the correct setup, generated the same exact table she intuitively generated first.
They got then down to the dependent and independent variables. Here they go again. Oh no, you know.
Racks are dependent on teams, right?
Yeah.
Well, how many teams you have? How many
So racks are dependent on teams.
So
that rack to be up here and teams to be down here, right?
I'm lost. So am I. Hey, Leah, what did you Leah?
And this one little girl, she says, okay, now in science class, so that integration, she says, he showed us how to do one of those little memory ditties, and she figured it out, and off they were again. And so everybody else was pulling, oh yeah, that's right, because every time they would go back, oh, that's right, that makes sense.
There were a couple of girls in this group who knew the mathematics.
Would 36 work for you guys?
36 I could use.
Get used to it. It's too small. 36 work for you guys?
24. Let's go 36.
Yeah, let's go on teams.
There were 3 or 4 leaders that came out at different times during the group's work. And each time they got a little bit further, because once they got the clue, then they were able to move on.
I believe with a child like Diana that this is a very powerful way for her to learn, because she learned from her peers.
Heidi made a remark. She said when she started to draw her line,
Doesn't it have to go through 0?
and nobody answered her, but she knew that. And so she made sure that when she drew it, it did go through 0. And there was a girl sitting right next to her. Hers did not go exactly through 0. She erased it, and she redrew hers, so it went through 0. So Heidi had them convinced by just her little statement. It has to go through 0, doesn't it?
I think the most interesting part of the thinking process that was going on was there were different people around the room that got them to focus. So they were all thinking because they were all being pulled back into that focus.
They did that graph 3 different times. And I saw it improve every time. I saw one on the paper that was kind of like, whoa, how did we get that? So by the time we got to the one on the wall.
Just go as far as you went on the last one.
8. Crooked.
35, 40, 45, That's fine. Yeah.
The light came on for the people who had their graphs, and I started to make
6. 8 would be around.
Right there.
Wait, you need to label it what it is first.
We got the top first.
8 here.
36, 27.
It's not going to be 35, 40, 45.
Oh. You just come on with it.
Whoops.
The light came on, and they changed it.
When we messed up like 3 times on the graph over there, we had to X out one of our dots and put a new one because we kept messing up. We had to make sure we had a straight line.
Do you think it was probably not in the numbers, but in how you were drawing
It
it?
was in our estimation.
And I think moving from the wall graph to the floor just reinforced whatever thinking they had. The hands-on portion of it reinforced their thinking.
Good. You need to write tokens too?
Hey, you guys are doing great. You're getting it all worked out.
When they moved from the wall to the floor, they were a well-oiled, highly organized machine.
Who's going to write 2s and racks?
I'm good at writing.
A whole other set of people took over. The fine motor skills went to certain people, and then the gross motor skills went to another group.
Okay, I'm done.
The hands-on exercise, it drew them into it. The kids that normally would be looking around and talking about other topics were very, very involved.
Put them on the points, man.
Yeah, but it has to be hanging over the side of the ear. So walk that on.
It'll hit home a lot better.
Excuse me. Okay.
I was assigned to observe student, and I observed Chris.
You got some fractions here?
Well, if you do it like...
You guys are sometimes multiplying, really confusing me.
Well, then how do we find the third one? What do we do?
The group process is good for Chris. When he gets into academic mode, he's a follower, but when he gets into the practical mode, he's a leader. I want to get his hands on things, and that's what's good about a lesson like this, because you're using not only the linguistic mathematical intelligence at first, but the drawing, spatial intelligence on the wall, and then the kinesthetic on the floor. So you had a lot of that stuff going on.
What they came to on the floor was they'd gone to 40 or 45. They decided increments of 5, and they ran out of markers, tick marks. And oh my goodness, what are we going to do? And Diana counted 5, 10, 15, 20. And then she decided, well, that's okay. We only went to 36, so we can go just a little bit past 35. Once again, mathematically in there. I was impressed because a child like Diana in other setting would have totally generated a bunch of mixed algorithms and not ever applied it or thought, and been just happy and gone right on. And she kept being drawn back to what makes sense, what makes sense.
And you said that the students earlier this year had already talked about cross multiplication. They had already talked about proportions. They had already talked about line of best fit. And yet when you give them a hands-on problem that they have to work themselves, it makes that mathematics come alive. So if this is the first lesson you do back in August 17th, or whenever we start this next year, and they've got this idea of proportional reasoning to work with throughout the entire year, just imagine how rich the mathematics is going to be.
By the time they get to us, they've had 7 years of multiply A times B. Today they had to figure out if they were going to add, subtract, multiply, divide, or walk to the restroom. And all of those were options. Math is really a series of successive approximations to the real world. And that's what the kids saw today instead of cookbook formulas. I really like that part of it. That's what they need.
You know, they just had the little cards with the numbers on them. And I noticed a couple of them kept switching and forgetting which one goes first and which one goes second.
You need to switch your paper around, David. David, make it, switch them.
And so Rachel told them, we'll label them that one is racks and one is teams.
Do we need to write what each thing is? Do we, like on the 8, do we need to put teams, and on the 6, do we need to put racks?
That's one way you could do it. Probably, you know, when you're doing this, it would kind of help determine at which point, which was the axis. So you'd know that that was 8 teams.
That was a great idea, and you picked up on that, and you commended her for it.
Yeah, I'll hold that.
Good idea, Rachel. I'm glad you noticed that.
It's so important that the kids know that, hey, those numbers are talking about something. It's not just a 6, period.
I like the presentations. The little girls, they really got into that, man. They sat down there and they practiced, you know. I could see them in their head. They're doing a CNN from Baghdad or something. But if we'd have had some kind of informal rubric about here's what your presentation needs to include to make them feel more comfortable, I'm more interested in your conclusions. And you tell a little bit about what you did get there, and then really focus in on the conclusions. But man, that was a great presentation, and with a little fine tuning, I think it'll be awesome.
It just occurred to me how important it is to have a strong conclusion so that we can really bring that knowledge back together.
What's something else about both the lines that you see? Look real hard.
They're both orange. They both go through 0.
Rachel, say it louder.
They both go through 0.
If I have no teams, do I need any basketballs? No, they both start at 0 and 0. Over here, if I don't have any tokens, can I play any video games?
No.
Guys, this is a special type of graph. It's called direct variation.
And I thought that Sherry did such a good job of introducing the term direct variation from there and bringing that in.
The change is always the same. It makes a straight line, and it always goes through what we call the origin, 0, 0.
One thing that I saw that I thought was good was leaving kind of an open-ended question for the kids. The question was, what 3 things do you observe when you look at the charts? How do they look? How are they similar?
During their reflections, I looked around on the papers, and there was one child, I think that was the intellectual leader of the group. She wrote down on her paper that both of the graphs was increasing, and I thought that was a big leap for an 8th grader that may not have studied graphs in depth or have had exposure to Algebra 1.
And there was such a variety of responses with the kids and their depth of understanding. They made the problem their own. It meant something to them, and I could see that they actually cared something about it.
More and more open-ended will, I think, draw and drive their thinking. I think they're ready to explore what would happen off that graph. And what would happen in the negative quadrant? Would it make sense?
One of the great things about a lesson like this is that it also gives you a lot of reference points to go back and do some additional teaching. When they all got up for the picture where they all held the pipe, and I think a neat one there would be not so much that it's a straight line, but why is it a solid line to begin with? Because if you notice when some of the kids are standing there that you only had 4 points, so only 4 kids had the little cards. But then you had some other folks in other spots that were still on the same line. So that can go, it's a good lead into a good discussion about why is the line solid, and this person didn't have any coordinates for that particular position, and maybe the kids can guess, well, maybe that's this X and that Y.
I heard a lot of students come up with the conclusion that, yes, our graph is going to be a straight line. But I thought maybe if they used something that was more flexible, like yarn or something like that, it might have been a little bit more of a challenge for them, because with the pipe, it almost forced them into that conclusion.
I would love to ask them to explain direct variation in their own words. I'm not sure they know what relationships are all about. What is a relationship?
That is a serious concept, proportional reasoning. If we had asked the children, what was the relationship, I think they would have immediately told us. They didn't say it, but I think intuitively they knew. They knew it. We just didn't, I guess, bring it out within the lesson enough.
We all intuitively know that children can think, they can process, and they can draw conclusions on their own. And I believe that one of our problems is we haven't supported the notion that kiddos can generate their own understanding of mathematics. And this is very, very evident even in this one little snapshot.
It speaks very well of students articulating the process, students having to defend their decisions. It also talks very well about when the teacher has to make a decision, when to intervene and when not to intervene.
I give them a lot of freedom. I try to step back, let them make the mistakes, and then, try to then guide them back to, what was the correct concept.
Most of everything that you said was a direction.
Are you having trouble with that tape?
Yeah, because it keeps on cutting it.
Is this group, are you through with your tape? This group's having a little bit of problem with theirs, so we're going to borrow it.
Yeah.
Okay, thank you, Jana.
There's very little mathematics tied to it. And I think that's great because we try so hard not to give away the answer that we want them to find. And you kept saying, now, be sure you do this, be sure you do this, be sure you do that. And you are looking for a relationship. But be sure you do this, be sure you do that. So she was constantly aware of not giving away the answer, and I thought that was great.
Okay. Do you want to take that? I don't care what languages, it doesn't really matter.
Oh, but it might matter.
Would it be easier if we did it by twos?
Yeah, we can both beat them up.
Then how about let's pick 3 then?
That's not
It's not. What do you? That's not an even. Oh yeah, it's not. How about 4 then? 4. We're going both ways.
And what I saw today was very encouraging because I saw something that I believe with all my heart that almost any teacher can achieve. If they sit down and actually study the process and collaborate about the lesson and work on it in practice and talk to each other as a team, that yes, they can produce a lesson that is taught in 2 different places and we get basically the same results, which is what we're trying to do. We're trying to make sure that all children receive a quality education regardless of where they are located. And I think this kind of approach to developing and talking about lessons is one way to achieve that.
Truthfully, I think this is one of the best things for teachers to be able to get together, find out what's working for all of us, fine-tune it like this, find out, because as the teacher out there, I didn't see a lot of this happening. I was busy trying to keep the kids working, you know, and you don't notice a lot of the small things. We need that input. That's what helps us grow.
Teaching for understanding is the name of the game. And if they don't understand it, as you know, they won't keep it. They'll keep this one for life. It was a joy to watch it. And I truly hope that we do continue to do this kind of lesson study